In class 12 physics, in the topic of electrostatics, look at this question. There are four charges of magnitude q lying on the vertex of rectangle ABCD. The length of the rectangle is 6 meter and breadth is 4 meter. You have to find out the net electric field due to these four charges at the midpoint of the side CD. How will you find out? Try it by yourself and then watch my solution. Now, first at point P, we find the electric field produced by the two charges located at vertex C and D. As point P is the midpoint, therefore it is at equal distance from the vertex C and D, which is equal to 6 by 2 means 3 meter. Also, the magnitude of charge at these two vertex are same, that is q. Therefore, these two charges will produce electric field of same magnitude at point P, which magnitude will be kq divided by 3 square. 3 is the distance of point P from the either of charge. Now, these two charges are positive in nature and electric field produced by positive charge is away from the charge. Therefore, electric field produced by charge at D will be in the direction of PC and electric field due to charge at C will be in the direction of PD. Clearly, the direction of electric field are in opposite direction. Now we have two electric field which are of same magnitude but their direction is opposite. Therefore, vector sum of these two electric field will be 0. So these two charges together will not produce any electric field at point P. Now we consider these two charges present at A and B. First, we find out the distance of P from A and B. As AD equal to 4 meter, DP equal to half of the 6 meter, that means 3 meter. So by Pythagoras theorem, we find out that length of AP is 5 meter. Similarly, length of BP will also be 5 meter. That means in this case also P is equidistant from A and B. Also, the charge located at A and B vertex are of equal magnitude. Therefore, they will produce electric field at P which have same magnitude. And it can be find out by the formula kq by r square and will be equal to k into q divided by 5 square. 5 is the distance of P from the charges. The electric field due to charge located at point B will be along the line joining BP and in away direction. Similarly, direction of electric field at P due to charge at A will be along the line joining AP and in away direction. So the net electric field at point P will be the vector sum of these two electric field, as the vector sum of these two electric field is 0. Therefore, now we have to find out the vector sum of these two electric field. Now the magnitude of the vector sum of these two electric field can be obtained by parallelogram law of the vector. For this, first we have to obtain the angle between these two vectors. Let me assume that this angle is alpha. As this triangle and this triangle is congruent, therefore this angle will also be alpha. Now this is alpha, so this will also be alpha. This is alpha, so this will also alpha. Therefore, angle between these two vectors will be 180 degree minus 2 alpha. As the magnitude of these two vectors are equal, so to make it simple, we assume it A. So using parallelogram law, square of the magnitude of net electric field will be equal to square of magnitude of this electric field, which is A square of magnitude of this electric field, which is also A square, plus 2 into magnitude of this vector into magnitude of this vector into cosine of the angle between these two vectors. Now we solve it. A square plus A square is 2A square. Cos 180 degree minus 2 alpha will be minus cos 2 alpha, and 2 into A, 2A square. So we will get expression 2A square minus 2A square cos 2 alpha. Now we take 2A square common. So in the bracket we will get 1 minus cos 2 alpha. And the 1 minus cos 2 alpha is equal to 2 sine square alpha. So we will get result 2A square into 2 sine square alpha. Now we take square root on both sides. Left side we will get the magnitude of net electric field and right side we will get 2a sine alpha. Now we put the value. In place of a, we put this value, and value of sine alpha we can find out from this triangle. The value of A is KQ divided by 5 square, means KQ divided by 25, and sine alpha from here we can find out that its value is 4 by 5. So we put 4 by 5 in place of sine alpha. Now if we solve it, we get the final answer 8KQ divided by 125. So the magnitude of electric field at point P is 8KQ divided by 125. As the magnitude of these two electric field is same, so the net electric field will be the angle bisector of these two vectors. It means net electric field will be perpendicular to the